Hello, how is everybody? Welcome to FM Tuition Academy. It doesn't matter where you're watching me from. You know you're somebody who's doing GCE or you want to write certain subjects. This is a place for you. So you can contact us, just comment your WhatsApp number down and our team will get a hold of you. Are you doing mathematics, physics, English, chemistry, biology, education, RE, all these subjects? It doesn't matter what subject you are doing. Just comment your WhatsApp line down and our team will get a hold of you. Okay, so today we are looking at indices. Okay, indices, that's what we're looking at. Indices. Okay, I love teaching students the shortcuts so that they know how to prepare for final exams. So I'm going to look at the rules of indices. The rules of indices. Okay. The first rule is, if I write a number like a to the power m over n, okay, this is called a base, and then that is called a power. So even if I write this or I write this, it's the same thing. So this part is called, this part down is called the base. Okay? And then this part on top is called the power. Okay? This is the base and that is the power. So even if I write something like, for example, I write something like a to the power b. So a is the power, a is the base because it is down. So the base is always down. The power is on top. So the base is down. The base is down. The power is on top. B is the power. That's the first thing that you are supposed to know. So whether it's this or this, here the power is a fraction, it is m over n. Here the power is just a number b. Okay? So the base is down, the power is on top. I repeat, base is down, power is on top. The base is down, power is on top. So if I write a number, let's say for example I write a number like I say 2 to the power 3. And then I say which one is the base here. So it means 2 is the base, 3 is the power. Okay? You have understood? That's what this means. So for example, if I write number 4, for example, this is number 1, number 2, number 3, number 4. I'm just first, before I even start giving you the rules, I was just giving you an introduction so that you know what indices are about. So if I write, for example, 4 to the power 3 over 4. Let me put 8 here instead of 4. 8 to the power 3 over 4. So 8 is the base. Why? Because it is down. 3 over 4 is the power. I hope you have understood and your mind has opened up. Let's look at the rules. So this was just an introduction, okay? So this is just an introduction. These are not the rules. These are just the introduction to make you understand what a base is. It is a number down or a letter down. The power is the one that is on top. Base is down, power is on top. Base is down, power 3 is on top. Base, which is 8, is down, power is on top. You see, this is on top. The power is on top. 3 over 4 is on top. 8 is down. Okay, let's look at now the rules so that we start dealing with the main thing, okay? So I'll wrap this. Let's look at the rules of indices, guys. The rules of indices. The first rule, rule number 1. Rule number 1. I'll be explaining them, okay, so that you have an understanding, okay? Okay, so the first rule is, if you are given, for example, a to the power m, multiplied by a to the power n. Can you see? The base is down, the power is on top, which is m. The base is down, the power is on top. When you are given indices having the same base, or when you are given powers, the power and the index is the same. If I say power and index, I mean the same thing. So if you are given index having the same base, this index is having the same base. So power, and if I say power and index, I mean the same thing. So if I say a to the power m, a to the power n, can you see the base here is same? It is a. If it's b. As long as these ones down, they are same. These two powers, m and n, are supposed to be added. So you maintain this, you add the powers. Maintain the base, add the powers. That is the first rule. If the bases are the same, maintain the base, add the powers. When you are multiplying powers, m and n, having the same base, simply add the powers, maintain the base. That's the first rule. This is the multiplication rule. The multiplication rule for indices. Okay? The multiplication rule. What about the division rule? If you are dividing index having the same base, what do? Maintain the base. You see, this base is still the same. You maintain the base. As long as the bases are the same, you are maintaining this base, subtract the powers. So it will be n minus m minus n. Okay? Maintain the base a, you subtract the powers, m minus n. Whenever you are dividing powers or index having the same base. So this is the multiplication rule, or the multiplication rule, or the product rule. Remember, product means the same as multiplication. So the product rule or the multiplication rule. This is the quotient rule or division rule, because we are dividing. I'm simplifying it so that you can understand. Okay, rule number 3. Rule number 3, what do you do? For rule number 3, for example, if a base is written to you raised to the power 0, any base raised to the power 0 will always give you 1. Any base raised to the power 0 will always give you 1. Meaning any number raised to the power 0 will always give you 1. I hope you have understood. Same thing here. Any number raised to the power m, if this is a number, for example, here it's 2, here it's 2. Meaning the numbers on top, you add them. So these can represent same numbers or same letters. AA, 55, 66, 77. Whatever is here is supposed to be here. Okay. Rule number 4. When we are dealing with examples, you understand. Rule number 4. Can you see this rule number 4? A base. Actually, the base is quite smaller. These are a bit smaller. The power is on top. Even this is smaller. Okay, small. The power is on top. 0 to the power a to the power 0. So a to the power m. You see, these two are powers, but the two powers are separated by a bracket. So this is power, a power to a power. Okay, a power to a power. The power to a power rule, a power to another power. Okay, there is a power here to another power here. Meaning, when a base is raised to a certain power, and then there is another power outside the bracket, you simply maintain the base, and then these two powers on top, you multiply them, because brackets means multiplication. So it means it's 2m to the power m times n, it is mn, or m times n. Let me just put it for you here. It is m times n, okay, which is the same as a to the power mn, because m times n is mn, okay? I hope you have understood this. I hope you have understood this, okay? That's what you do. And then rule number 5. Rule number 5, if what is in the brackets, a fraction raised to the power n, what does this mean? It means this m is given to a, at the same time the m is given to b. So this simply means a to the power m over b to the power m. The m is distributed to the numerator, at the same time the m is also given to the denominator. I hope you have understood those rules. Okay? I hope you have understood. So this, it can also be a fraction raised to a power. When a fraction is raised to a power, this is a rule. When a fraction is raised to a power, that power give it to the number on top and the number down. That's why the power is given to m, to a. The power m is given to a, at the same time the power m is given to b. So this can also be written like this. For example, if I write a over b like this, okay, I'll write it on top because of space down. Okay, let's look at the first five rules. So I'm going to wrap this one on top since you have already written. So I'll write the 60th rule here, which is the extension of this one. For example, if they give you this is the 60th rule. If I say M, A, B, and then here I put, let's say, M, and then here I put N to the power 2. Okay? What do you do? What do you do? Okay. So when it's like this, guys, what do you do? Okay? Oh, I'm supposed to use letters. Sorry. This is, let's say, let me put Z, for example. Z is or Y for easy understanding. So when it's like this, I said bracket means multiplication. So this y is given to this power, at the same time y is given to that power. Okay, so this can also be written as a m times y b n times this same y. Okay, the y is multiplied to m, at the same time this y is also multiplied to n. That's why it's written like this. I hope you have understood and you are picking some ideas. Okay? 7th rule. If they give you, let's say a, b to the power m, two numbers raised to the power m, they are in brackets. M belongs to A, the same M belongs to B. So it's the same as I write A to the power M, here it means times B to the power M. This M is given to the first number, the second number, or the first letter, the second letter. So it's the same as if I write any number on its own. For example, if I say A to the power B, and then I say C to the power D, and then I put them in brackets like this, and then I put M outside. Okay, if I write the numbers like this, A to the power B times, there's times. If I don't put anything, it means it's times. C to the power D. It simply means I maintain A. Okay? I maintain A. This B will multiply with the M. So it is B times M. What is outside the bracket always multiplies with what is inside. Times C to the power D times the M also. Have you seen the way we have written it? This M multiplies, since M is a power, it will multiply with B the power. That's why it's like this. M is a power when you multiply with B the power. That's why it's like that. Okay? Ninth rule. If A is raised to a negative power, a negative fraction like this. Okay? For example, A to the power 1 over N. To make this into a positive, I mean, if it's like this, rather, if a number, let me write it like this, A to the power, let's say, B over C, so that I make you understand. When they write it for you like this, okay, A to the power B over C, A to the power B over C. The first thing that you do, this can also be rearranged as, you put a square root like this, okay? And then, you see there is a denominator down and the numerator. So this one which is down, the denominator always comes here. C will always come here in front of the square root. C will always come here in front of the square root. So it means A will be in the square root. It will be written like this. B will come as a power. This rule is very important. Majority of your calculations for ECZ have to do with this rule. This one. You need to master it. That if A is raised to a fraction, what do? You can rearrange it as the cube root. C will be in front. This number down will always be in front of the square root. If here it's 4, you put 4 here. If here it's 5, the fifth root. Then this one on top will also be on top here. Okay? So you put your A here, then you put your square root inside the A. I mean, you put your A inside the square root will come like this, then your A will put it inside. Then this number down will be the first number in front of the square root. This number on top will also be on top there. Just remember that, the number on top, I put it on top this side. The number down here, I put it in front. That's how you write it. Okay. Okay, I think we close. I show you the last rule. Just the last one, the last rule. I show you the last rule, guys. The last rule. Okay. I can't remember, that was number what? Was it number 10? I can't remember the number, forgotten, since I've wrapped. But it's a continuation. Let me name it number 11. I don't know, I've forgotten the one we wrapped. That was number what? But I'll explain. So, for example, they give you A to the power B over C, it has got a negative here. You remember, the one that we are dealing first, it was just like this, huh? It was like this, but there was no negative. You remember the one that we are from doing, where we put A inside the square root, huh? The one we are from doing, we had to put this inside the square root. And then C was in front, B was on top. Now, when it has got a square root, the first thing that you do is, you get rid of this square root, you introduce one on top. Then you say over. This, you bring it down the way it is, but the negative will disappear. So it will be A to the power B over C. The negative disappears. You disappear the negative by dividing by 1. This is a power. You disappear the negative. When you introduce one on top, then the negative will disappear. This whole thing comes down. Okay. That's a bit about indices. Okay, let's just now look at the actual work. Let me just look at the actual work. Because I want us to concentrate. These are just the rules. Let's start looking at examples. So I'm not going to spend long on the examples because I just want you to understand the principles. Okay, example 1. I'll just solve maybe 2 examples on each. For example, example 1, this it's written, simplify a, for example, that is a 2 to the power 2 times 2 to the power 3. You remember what I said? When you are doing this, what do you do? When you are multiplying powers having the same base, the base are the same. You maintain the base, but the numbers on top you add them, the powers. So 2 plus 3, which will be equal to 2 to the power 5. Are you seeing what I'm saying? The rule, the first rule, the product rule, says when you are multiplying numbers having the same base, when you are having these powers rather, you are multiplying powers having the same base. Maintain the base, add the 2 powers. Okay? So that is the first example. The second example, if we say for example 3 to the power 4 times 3 to the power 5 times 3 to the power 2. What did I say? How do you solve this? You check the base first. I'm multiplying powers having the same base. The base is same. Maintain the base, but the powers add them. This rule only works when the base is same. If here it's 2, it cannot work. It only works when these ones down are same. So what do you do for this? You say 4, you said add the powers, plus 5 plus 2, which will give me 3. 4 plus 5, 9, plus 2, 11. So it is 3 to the power 11. I hope you have understood. I've simplified that. The same thing goes on to when you are dividing. For example, this is, if I say 2 to the power 3 divided by 2 to the power 2. When you are dividing powers having the same base, what do? You maintain the base, but these numbers on top, you subtract them. So 3 minus 2 is 1. 1. Okay? Maintain the base, subtract the powers. Okay. If I write 3 to the power 4 divided by, let's say 3 to the power 5. Okay? Also this side, let me say divided by 3 to the power 2. How do you solve such an equation? First you check, I'm dividing powers having the same what? Base. Base is same, but I'm dividing. So it will be 3 to the power 4 minus 5 minus 2. 3. 4 minus 5, it is negative 1. 4 minus 5 is negative 1. Negative 1 minus 2. So 4 minus 5, negative 1. Negative 1 minus 2, negative 1 minus 2 will give you negative 3. That's how we have negative 3. So this will be the answer. I hope you have understood. Okay. Let's come out from here. So these are just introductions, guys. These are simple things. Okay? These are simple things, guys. Simple things. Okay. Okay. So the next example. For example, if not examples, okay, exercise rather. Example. So this is example 2. What we are solving was example 1. So example 2, if for example they give you let's say 2x to the power 3 over 2 times 3x to the power 1 over 4. I've already taught you this. What do you do when they give you something like this? Okay, so 2 to the power 2x, it means 2 times x. 3x to the power 4, it means 3 times x. What do you do? This simply means you multiply the numbers first. So you multiply 2 times 3, okay, times the letters, you multiply them together. So x to the power 3 over 4 times x to the power 1 over 4. Have you seen? So this will give you 2 times 3, 6. When you are multiplying powers having the same base, you see this base is same, we simply add the powers. So it means you are adding 3 over 4 plus 1 over 4. So I'm going to do a sub calculation this side to simplify this. So I'm adding 3 over 4 plus 1 over 4. What do you do? Common denominator, 4. 4 into 4, 1. 1 times 3, 3 plus 4 into 4, 1. 1 times 1, 1. This plus this is what? 4 over 4. 4 into 4, 1. 4 into 4, 1. 1 over 1, which is equal to 1. So this simply means it is 6 to the power 1. Which is the same as 6. I hope you have understood. So that's what you do. If it's a fraction, you simply add those fractions. If it was division here, meaning these ones here will be subtracted, you follow the same process. Okay? If the answer here, for example, if the answer here maybe we found 3 over 4, meaning here the power, you are going to put 3 over 4. 6 to the power 3 over 4. Okay? Oh, x rather, sorry. Yeah, I was too fast. Sorry. I was too fast. So, I was too fast. I forgot to put. So, x comes here. We said we add the powers, right? So, let me show the addition here. So, 3 over 4 plus, this is 6. The powers are on top. We are adding the powers. 1 over 4. So, it will be 6. 3 over 4, when added, you get 1. So, 3 over 4, when I added this, I got 1. So, it is 6x to the power 1, which is the same as 6x. I hope you have understood. If the answer here we found was 3 over 4, or 5 over 4, meaning it will be x to the power 5 over 4, after adding this. Okay, so this applies with the division. Okay, so this is the same. This is 1. Okay, I'll remove this. Let me use division, but the same example. But here now I'll put division 9. Okay. I'll use division, but I think you have understood. Let me just proceed to a more simplified division of x, but here to be subtraction. Let me use division, okay, for example, let's say 2 to the power 2 to the power, okay, let's say x, let me use the same, okay, this divided by 4x to the power 1 over 4. How do you divide this? Okay, so the same principle follows. So what does this mean? Because this is a fraction now. Okay, so what do? You put the numbers. So for example, what I mean is, this is 2 divided by 4. Let me put it in a way that you can understand. Let me put it like this. Division. So it will be 2x to the power 3 over 4 divided by 4x to the power 1 over 4. Can you see that? Now, it's like this. You already know that 2 and 4 are a factor. Okay? 2 into 2, 1. 2 into 2, 1. 2 into 4, 2. So 1 over 2. And then here in front, it's like this. 1, 2. This is x to the power 1 over 4. And then here it is x to the power 3 over 4. Okay. So, I'm dividing this and this. This and this is the same as, if I write something like this, x, it means this x is also dividing this x. So it means these bases are the same. It's the same as I write this. What I mean, this in another way, this, it means this, right? So I make you understand. This also means this. Because here it's times. So times x to the power 3 over 4. This slash means divided by. Where can I put space? I can say 1 over 2 and then x 3 over 4 divided by x 1 over 4. Okay? This is what it means. This half x 3 over 4 divided by x 1 over 4. So this can also be written as, I'll wrap this part here, can also be written as, this can also be written as 1 over 2 when you are dividing indices having the same, when the bases are the same, you simply subtract the powers. That's what I said. So it means x 3 over 4 minus 1 over 4. Okay? Like that. Okay? When you are dividing the bases, you subtract the powers because the bases are the same. So it's the same as I do another subcalculation for this. 3 over 4 minus that. So I have to divide this. So common denominator, I have to subtract this. A subcalculation for this. So common denominator here it is 4. 4 into 4, 1. 1 times 3, 3 minus. This into this, 1. 1 times 1, 1. Okay? So it will be 2 over 4. 2 into 2, 1. 2 into 2, half. 2 into 2, 1. 2 into 4, 2. So this is the same as I write it like this. To the power x, when the 2 are subtracted, they give me to the power half. This half comes. Okay. Okay. So I'm just going to solve maybe 2 or 3 examples, and then I'll name this one as part 1, and then we deal with part 2 next time, so that I don't overload you with too much work. You may have too much work. You may have too much work. Okay, that's a bit about that. Okay. I've explained that. Let me explain the other part. Example, this was example 2. Example 3. Okay. So, simplify 2 to the power 4. How do you simplify such an equation? So 2 to the power 4, 2 to the power 4, how do you simplify it? You just say 2 times 2 times 2 times 2. 2 to the power 4 does not mean 2 times 4. 2 to the power 4, it means 2, you are multiplying it 4 times itself, which will give you 2 times 2, 4 times 2, 8, 8 times 2, 16. Please get this. 2 to the power 4 does not mean 2 times 4. 2 to the power 4 means 2 multiplied 4 times. If I say 2 to the power 5, I mean multiplying 2 5 times. 2 times 2 times 2 times 2 times 2. 5 times. If I say 2 to the power 9, I mean multiply 2 9 times. Okay? So that is it, question 1. Question 2. If, for example, I say 2 to the power negative 4. You remember what I said? I said when the power is negative, introduce 1. So how do you simplify this? You are going to simplify this by saying you introduce 1. You put 1. Once you put 1 on top, the negative disappears. So it will be 2 to the power 4, which is going to be equal to 1 over 2 to the power 4. It means 2 times 2 times 2 times 2, which is equal to 1 over 16. That's how you do it. 1 over 16. That's how you do it. 1 over 16. That's how you do it. 1 over 16. I hope you have picked an idea, guys. Okay. That's a bit about that. Okay. This is example 2. Example 3, on the same simplify. If they give you, for example, example 3, let's say they bring a question like 3 to the power 2 in closed brackets to the power 3. Okay? What did I say about such things? How do you simplify this? I said when there are 2 powers, 1 power inside, 1 power outside, you multiply them. So when you are solving this, you are simplifying this. Simplify this. It means maintain the base, but the powers multiply them, because bracket means multiplication. So it will be 2 times 3, which will be equal to 3. This times this, it is 6. 3 to the power 6. Are you see? Okay. Example 4. What about if they give you, okay, I'll wrap this because of space. I write example 4 here. So example 4, what about if they give you something like, let's say 3 to the power 2 in closed brackets to the power 3. What does this mean? So I said any number which has got a fraction and then it is raised to a certain power, this power is given to the numerator and the denominator. So this means 3 to the power 3 over 2 to the power 3. And 3 to the power 3, what does it mean? You are multiplying 3 times, 3 times 3 times 3. 2 to the power 3 does not mean 2 times 3. It means 2, you are multiplying it 3 times. 2 times 2 times 2. 3 times 2, multiplying itself 3 times. Which is this times this, 9 times this, 27. 27 over 2 times 2, 4 times 2, 8. Like that, guys. I hope your mind is opening up and you are beginning to get acquainted to some tips on how this is done. Okay. So those are just some of the tips. Okay. Okay. Lastly, let me give you the last example. I want to give you the last example. Okay? Or let me give you just an exercise for now. I'll continue in part 2 so that I don't panic you with too much work. Okay? exercise. So the exercise is here. This is the exercise. Okay. Simplify 1, 2 to the power 4 close to the power 3. 1, 2. Three raised to the power -4. Simplify 4x to the power 5/2 divided by 3, or rather divided by 3x to the power half. And then the last question, the same one, but here it's times 5/2 times 3x to the power 1/4. Okay. Question 5. Okay, maybe this is enough for now. Let's try those 4 questions. Try those 4 questions, post your answers, then I'm gonna mark you. We'll deal with part 2 later. I don't want to make you too tired. I'll stop there for now. I'll stop there for the meantime. Okay, so we end there for today. For today, we actually end there.